So in this video, we're going to be starting chapter 1. Just wanted to have a very quick discussion about where we're at in the course. So chapter 1 is all about equations and inequalities. And the reason we do chapter 1 is really to give us the tools that we need to do chapter 2, which is called linear programming. In linear programming, we'll be able to maximize or minimize a quantity when there are some restrictions involved. So a classic example would be if a company is trying to maximize profit with limited raw materials, that would be a linear programming problem. So we'll think of all these tools that we're building up in chapter 1 as just setting us up to solve some interesting linear programming problems that apply to the real world. So in section 1.1, we're going to be talking about coordinate systems and graphs. And very first thing we're going to do is just plot some points on the XY axes. So we've got these 4 points, A, B, C, D. We're going to graph our X and Y axes. So X is the horizontal one, Y is the vertical one. And let's go just 3 units in each direction. So you can indicate some scale there. So the point A is the ordered pair 2, 3. You always give the X coordinate before the Y coordinate. So we're saying X is 2, Y is 3. Point A would be there. For B, X is -2. So that's over on the left side. And the Y value is 3. So there's B. For point C, -2, -3. Okay, so that's going to be left and down. Point C is there. And point D, X is 2 and Y is -3. So here we go for point D. So that's just a very quick refresher of graphing on our usual X and Y axes. So next example, we're going to do some practice with lines. Let's consider the line 21x plus 7y equals 14. First thing we're going to do is put this into standard form, y equals mx plus b. Okay, this standard form that our course pack refers to is sometimes also called slope-intercept form. So we want to make this line look like y equals mx plus b. All right, so in other words, we want to start with this equation here, and we just want to isolate the y, get it on its own. So let's subtract 21x from both sides. 7y would be -21x plus 14, and then we can divide through by 7. So we just need to make sure to divide every single term by 7, and we'd have y equals -3x plus 2. And there we have our slope-intercept form, or you could call that standard form. So the idea is that now we've got it into the standard form, y equal mx plus b, it's easy to pick out the slope. So the question is, what is the slope of this line? Well, once you've got your line into the standard form, y equals mx plus b, the slope is just going to be the number in front of the x. So the slope is going to be -3, and the symbol that we're going to use for slope is m. So we'll write m equals -3. It's also very easy to pick out the y-intercept. So again, you can do this once you've got your line into standard form, as we had in part A. The y-intercept is just going to be the number. So it's the 2. And the symbol that we're going to use for the y-intercept is b. So b equals 2. So just a caution here that you have to be looking at the standard form of the line when you pick out the slope and the y-intercept. So if you had a line written like this, like we're seeing up at the top of the screen, at this point you're not ready to pick out the slope and the y-intercept yet. You have to take it all the way to standard form where the y is really isolated. So once you've got y on its own, then the right side of the equation is going to be mx plus b, and you can pick out your slope and your y-intercept from there. So next thing we're going to do is calculate the x-intercept for this line. And before we get into the algebra, I'm just going to draw a picture. So imagine that you've got some line. I'll draw it in blue here. The x-intercept is the point where that line crosses the x-axis. So that would be this point right here. And the way that you find the x-intercept is actually by setting y equal to 0. Because if you think about what the x-axis is, think about this horizontal line here. The equation of the x-axis is y equals 0. All the points along this x-axis have y value 0. So by setting y equals 0, that helps you find this point where the line crosses the x-axis. Okay, so let's write down what we just said. General instructions for finding the x-intercept. You're going to set y equals 0 and just solve for x. So I think I'll look back to the standard form that we had from part A. We've got it right up at the top of the screen. Y was negative 3x plus 2. And to find the x-intercept for this line, we're going to set y equal to 0. So 0 equals negative 3x plus 2. And we're just going to do a little bit of algebra here to solve for our x value. So let's subtract 2 from both sides. Negative 2 is equal to negative 3x. And then we can divide by negative 3. So negative 2 over negative 3 is equal to x. In other words, x is equal to 2/3 if we just divide top and bottom here by negative 1. If you wanted to write that as an ordered pair, the x value 2/3 and the y value 0. So you can give your answer either way. You can just say x is equal to 2/3, or you can say here's the actual ordered pair. Whenever you're talking about the x-intercept, the y value will be 0. So I'm just going to rewrite this standard form of our line up at the top of the screen because we're going to do a few more parts here. Part E, let's ask, is the point 1, negative 1 on the line? So the way we're going to answer this is we're going to sub the x and y values into the line and see if it makes the equation true. So your x value is always your first number. X is 1, y is negative 1. So let's sub that into the equation up at the top of the screen here. So we'd have negative 1 is equal to negative 3 times 1 plus 2. Okay, and we don't know whether this is true or not, so I'm going to put a question mark here. If this is true, then yes, the point is on the line. If it's not true, then the point is not on the line. Okay, so looking at the right side here, negative 3 times 1 plus 2 does give us negative 1. So this is true. The answer is yes, and that means yes, the point is on the line. Let's do a second version of that. We'll just change our point. Let's ask, is the point 2, 1 on the line? So now we're just subbing a different combination of x and y values. X always being the first number, so x is 2, y is 1. Let's sub that in. And what we're subbing into is our equation that we've got up at the top of the screen here. So as we sub in, this would look like 1 equals negative 3 times 2 plus 2. And again, we're asking the question as to whether this is true or not. So let's look at the right side here. Negative 3 times 2 plus 2, that gives us negative 4. So 1 is not equal to negative 4. And the answer is no. So that equation is not satisfied, or the equation is not true, you could say, and therefore the point 2, 1 is not on the line. So last thing we're going to do is plot the line. And again, I'm going to write the standard form over on the right side just for reference. The line that we're working with, y equals negative 3x plus 2. So let's think about how to use the slope and the y-intercept to plot the line. First thing I'll do is just draw our x and y axes here. So we figured out that our y-intercept is 2. That's just coming from this number in the standard form. It's telling us the y value on the y-axis where this line crosses the y-axis. So at y equal 2, line crosses the y-axis. Okay, and then let's think about what this slope tells us. The slope is the number that's multiplied by x when you've got your line written in standard form. And what the slope tells you is what the change in y is as you take one step to the right. So imagine taking one step to the right. We're now at x equal 1. The change in y is negative 3. So I'm going to put a little bit more scale here. Let's say this is negative 1. Let's say that's positive 2. Here's our x value 1. So as we take one step to the right from our y-intercept, y has gone down by 3. So instead of being at y equal 2, we're now at y equal negative 1. So we've got this point also on the line. And that's how we use the slope and the y-intercept to graph the line. So just as an aside, I think I'll do a second example just illustrating how we use the slope and the y-intercept to plot a line. So let's say the standard form of your line were y equal 4x plus 1, for example. So quick way to sketch this, you would say, this 1 is my y-intercept. So crossing the y-axis at y equal 1. And then this number here is your slope. So that tells you how much y is changing as you take one step to the right. So step over to x equal 1. Our slope is telling us that y is going up by 4. So instead of now being at y equal 1, we're going to be up at y equal 5. So that's what's happened as we've taken one step to the right, we've gone up to y equal 5. And there's our line. In part G, we had a negative slope. So when you have a negative slope, your y value is going to be decreasing. We can see our y value decreased by 3 units, and you can actually draw on here. You can say that's 3 units that y decreased by. Whereas in our second made up example here, y equal 4x plus 1, we had a positive slope. And so you can see the y value is increasing now. It's increasing by 4 as you take a step to the right. Couple more short examples to help us with slope and y-intercept. Let's say we have a line like y equal 3. Well, that represents a horizontal line, because if you think about all the points that are going to have y equal 3, they're just going to be sitting horizontally like this. These are all the points that have y coordinate 3. So y equal some number is always going to be a horizontal line. And when you have a horizontal line, the slope is 0, and the y-intercept is whatever your number is here. So if your line is y equal 3, then your y-intercept is 3. A different way of looking at this is if someone gives you the equation y equal 3, you could rewrite that in standard form by saying, oh, that's the same thing as y equals 0x plus 3. And then you can say that number is your y-intercept and that number is your slope. And then let's talk about the other special case, which is vertical line. So a vertical line has an equation like x equals something, x equal 3, for example. So if you plot all the points that have x equal 3, here's x equal 3, so you'd be capturing all these points here. And if you capture all the points that lie on that line, you're getting a line that looks like this. So x equals something is a vertical line. If we think about the slope and the y-intercept of a vertical line, turns out they're both undefined. So m and b for a vertical line are undefined, meaning it doesn't make sense to talk about them. Essentially, that's happening because this line is rising so steeply. It's rising infinitely steeply or infinitely quickly, and so you can't talk about that slope. Similarly, the y-intercept is undefined because this line just doesn't cross the y-axis, so it doesn't make sense to talk about the y-intercept. So you can't write the equation x equal 3 as y equal mx plus b because there is no y in this equation. So that's another way of thinking about the fact that the slope and the y-intercept should be undefined for a vertical line. So let's put some of these ideas into practice. We're told that the annual car insurance for a 2010 Honda Civic in a small city costs y equal 65x plus 712, where y represents dollars, so the actual cost of the insurance, and x represents the years after 2010. So what we're talking about here is how the cost of the insurance changes over time. First thing we're going to calculate is the cost in 2015. Well, to solve this problem, let's figure out what our x value is. We're told in the problem, x represents the number of years after 2010. We're interested in the cost in the year 2015. So we're going to go 2015 minus 2010 gives us 5. So we're going to sub x equal 5 into the equation for our line, which is y equals 65x plus 712. And this y value is going to tell us the cost of the insurance in that year. So let's plug in. Y is going to be 65 times 5 plus 712. In other words, y is 1,037. So if you want to answer the question specifically, that's the number of dollars or the dollar cost for the insurance. So your insurance for that year, 2015, is going to be $1,037. So in part B, let's ask, in which year will the cost be $1,167. Well, remember we're told in the question that Y represents dollars and X represents the number of years after 2010. So if it's a dollar value that we're given, then this is like saying it's a Y value that we're given and it's X that we want to solve for. So we're going to sub Y equal 1167, put that into the equation for our line, which is the equation given in the question. Y is 65x plus 712. Let's sub in and see if we can get X. So 1167 is equal to 65x plus 712. Let's subtract 712 from both sides. So we'd have 455 is equal to 65x. And then we can divide through by 65. So that's going to give us 7 equals X. The question is asking in which year will the cost be such and such. So X equals 7 is not quite our answer. We just need to think about what X represents. X is the number of years after 2010. So the actual year is 2010 plus whatever our X value is. In this case, our year is 2017. So in 2017, the cost will be $1,167. And then final part to this question, part C, we're going to interpret the y-intercept. So let's just think back to our discussion of lines. Imagine you've got any old line. Y-intercept is the point where the line crosses the y-axis. And the y-axis has equation x equals 0. All the points on the y-axis here have x value 0. So let's see if we can figure out what the coordinates of our y-intercept are for this particular line, and then we'll interpret that in the context of the problem. So let's look back at the question and see what we know. Well, we were given the standard form for the line, and whenever you've got your equation in that form where y is on its own on the left side, then you can just pick out your slope and your y-intercept. So we can look at this line and say, oh, the slope is 65 and the y-intercept is 712. So let's write down b equals 712, or better would be to write that as an ordered pair. So when you're talking about the y-intercept, the x-coordinate is 0 and the y-coordinate is whatever your value of b is. Okay, now the question is saying interpret the y-intercept. So what this means is we need to put this into the context of the problem. When you say x equals 0, remember in this problem what x represents is the number of years after 2010. So the year is 2010 plus x. And if x is 0, then we're saying we're just talking about the year 2010. And let's think about what y equals 712 represents. Well, y represents the cost of the insurance. So $712. So to say interpret the y-intercept really just means put these two values together into a sentence. So we would say something like, in 2010, the cost was $712. So in our example, let's just have a sense of what our graph looks like. That's telling us if you were to graph the line representing the car insurance cost, the y-intercept would be here. So in 2010, the cost was $712. And because the slope was positive in this problem, the slope was actually 65, every year your insurance is going up by $65. So that's our video on coordinate systems and graphs. Thanks for watching.